Engineering Dynamics Session 7, a kinematics of a particle. Let's talk about a projectile motion. Let's solve an example in a projectile motion, which we had reviewed the formula in previous video. So in this example, we do have a chipping machine, which is designed to eject wood chips at a 25 feet per second. So V naught is 25 feet per second. As shown in figure below, if the tube is oriented at 30 degrees, so we do have the angle of our projectile, which is provided 30 degrees from the horizontal. We want to know what is the height, when the chips strike the pile. So there is a pile of chips and we want to know what is this h. If the original h from here is 4 feet, we want to know what is this elevation. So that's definitely smaller than the pile. If the instant and the land and the vertical distance, the horizontal distance of the chipping machine and the pile is 20 feet apart. 20 feet apart, yep. So let's talk about the velocity first. So our velocity has two components of Vx and Vy. If V naught is 25 feet per second, so V naught x is V naught cosine of 30 degree, which is 25 times cosine of 30, which is sine of 60 degree. That's 21.65 feet per second. And V naught y is V naught sine of 30, which is cosine of 60, and that's a 1/2. That's 25 times 1 over 2, that's 12.5 feet per second. That's the two component of our velocities in 2 dimensions. So we do know in x direction, Vox is V naught x is Vax, because it's Ax is equal to 0. So velocity at the first and velocity at the last remains the same. And we do know Ay is 32.2 feet per square seconds in British units. So in a horizontal motion scenario, we do have xa is equal to x naught plus v naught times travel time. So if we do know the chipping machine is 20 feet uh, in length apart from the pile, chip pile, that's a x naught, which is at the origin, that's 0, plus v naught, which is, that's a definitely v naught x, because we are talking about x direction. That's 21.65 times travel time from O to A. And it just gives us, if you do the math, it just gives us something like 0.92 seconds to travel from the chipping machine to the piles, or a stick pile. And in a vertical condition, we do have YA, height of A. From the same origin, we consider this height. I mean 4 feet. That's y naught plus y0 naught t plus a half of g times t squared. So that says, if we just take the y naught in the first part of the equation, that says h minus 4 feet, which is y naught, is equal to 0 plus a 12.5. It's even, we don't need this one anymore because we took it here. That's a 20.5 times time v naught y, which is 12.5 times the travel time, which is the same, minus a half of g times t squared. If you do the math, it just gives you h is equal to 1.8 feet, and that's this height, and h is 1.8 feet from the same origin which we consider the height of chipping machine stands at. In it was an example of a projectile motion. And next time we move to the basic of kinetic of motions, and start the relation which involves the relation of force and motion. Thank you.